The footage shown is centered around the boreal forest, which is a forested region that is in Canada and many other northern countries. The boreal forest is composed of many different tree species and wildlife species. Some tree species include birch, aspen, jack pine, tamarack, and balsam fir. Now, this region is incredibly important due to the biodiverse wildlife it supports and the oxygen this forest produces for us to breathe. Now, the boreal forest is expanding northward away from its southern boundary as the trees in this forest aim to migrate due to the rapidly changing climate in this region. Tree species such as jack pine and black spruce migrated northward following the retreat of the glaciers thousands of years ago. Forests have always migrated in the past, but usually at a very slow pace over hundreds of years. But due to our planet warming quicker than normal, some tree species like jack pine and black spruce, which fossil records indicate had moved roughly 0.3 miles per year in the past, may not be able to migrate fast enough before they meet their demise. Energy-intensive activities, like the one in this video clip of Canadian sand oil extraction, greatly contribute to furthering climate change and increase our reliance on fossil fuels as we create a bigger need for oil to extract these natural resources from a region like Canada. By furthering the use of fossil fuels, we will increase greenhouse gas emissions in this region and around the globe, which will further contribute to the migration of the boreal forest as it tries to adapt to a rapidly changing climate that it is not used to. Researchers like Price et al. Have discussed different ways in which climate models anticipate the consequences of climate change in the boreal forest region in Canada. Within this article, the authors discuss various climate models that paint a grim future for the climate of Canada's boreal forests, creating unrelenting stress on this sensitive ecosystem. Figure 5 displayed above particularly has to do with the change in climate moisture index in the region of the boreal forest we're looking at, and how the model predicts the change to occur over the next 90 years or so. Figure 1 in this article dives deeper into the ecozones and permafrost distribution in boreal Canada. These different ecozones in this region are also at constant threat of increased migration due to climate change. This map shows the permafrost extent in this region and how far northward it extends in the boreal forest region. And as the permafrost melts, it will further cause unrelenting stress on this sensitive ecosystem, but I will dive into more of that later. Logging in the region represents a large economic factor, but logging in general might be doing more harm than good as we continue to harvest the plentiful natural resources within the boreal forest. The boreal forests also play a crucial role in watershed protection for this region's freshwater bodies. Without the boreal forest, water quality in these bodies of water would decrease greatly, further creating a domino effect of perpetual, irreversible change which will impact thousands of wildlife species overall. As the permafrost melts in this region, the clips above show a drunken forest, which occurs when the permafrost quickly melts due to climate change, and the trees start to lean over in the side and topple over time. This effect is only exacerbated by our increasing temperatures in the climate. But it also provides a striking visual of what permafrost melt looks like above ground, since it can be hard to see and describe it below ground, since it's underneath the soil. The melting permafrost creates a positive feedback loop, which only leads to an increase in melting, which will then lead to an increased rate of boreal forest migration and overall forest stress. Speaking of forest health, pictured above is the spruce budworm, and then the next picture will show the mountain pine beetle. These are some visuals of insect pests that will be able to further migrate northward due to our warming climate. This will add additional stressors to the boreal forest and make it even unhealthier than it already is. This reinforces the idea that our climate warming faster than the forest can adapt to will be detrimental to the survivability of these tree species in this region. Furthermore, Mirabel et al. Found that smaller trees in the boreal forest may be increasingly prevalent in the future due to a change in the vapor pressure deficit that is occurring due to our warming and changing climate. This is an extremely important facet of the issue at hand. Smaller trees are less efficient in economic logging market terms, and they are also worse at storing carbon than larger trees are in general. This will mean less carbon will be stored in the trees and more ends up in our atmosphere, which will increase the potency of the greenhouse effect and further increase the positive feedback loop that is occurring due to climate change and all these other factors. Not all hope is lost for the boreal forest, however. If we do utilize more renewable energy sources and rely less on fossil fuels over time, then less warming will occur on our planet. And hopefully, it can be effective in mitigating the future migration of the boreal forests, as we look to reduce the accelerated warming of our planet. It is an important mitigation strategy we can utilize to help reduce the stressors that these forests and forest ecosystems across the globe are experiencing. By doing so, before we reach the tipping point of no return, we can retain these unique and vital ecosystems that provide so much economic, environmental, and aesthetic benefits to people who live around them.